Aquaba to the math classroom. Let's take an example of an exact differential equation. So we have a differential equation you would like to solve. And to do that, you would first want to check if what the differential equation is what exact. And to check if it is exact, if you have a differential equation of the form, so I have a differential equation of the form m of what m dx plus what n dy to be equal to 0. We are saying it is exact. It is exact if the partial derivative of m with respect to y is equal to what the partial derivative of what n with respect to what x. Okay, so here what do we have? We have m xy to be equal to what y squared minus 2x. Then I have n xy here to be equal to what 2 what xy. So let's check if it is what exact. So I want to find the partial derivative of m with respect to y. What do I have? Because this is x, so it's just constant, so it will go to 0. So you realize that I have what 2 what y. Then if I pick the partial derivative of n with respect to x and solve, what do I have? If I differentiate this with respect to x, it means I have what 2 what y. So you realize that this is what equal to what that. So this implies that the ordinary differential equation I'm looking at is what exact. Okay, so if it is exact, in our previous example, we looked at integrating the two functions. But another way you could look at is you could integrate one. So I could just pick so let's do it slowly and get it right. So I can integrate. So let's say I integrate one part. So integrate, let's say I integrate m of what x what y. And if I do that, you realize that, so I have the integral of y squared. So I have what m is what y squared. So I am, it's y squared, very good, minus what 2x the what x. If I integrate this, what do I have? Using the sum rule, you realize that this is going to give me, so let's say this is equal to what u. So this implies that u is equal to what x integrate y squared okay, so y squared minus, if I integrate this part, what do I have? X what squared plus a function, and this function is an arbitrary what function, but this function is going to be what a function of what y. So a function of y. So this is my constant. Then the next thing to do is I can, so let's say this is one step. Another step is differentiating the function I have. So I differentiate the function with respect to y, which is what the constant what function. So Let's change. So differentiate u. Okay, so if I differentiate u, I have what? The partial derivative of u with respect to y, which is going to give me what? 2xy. Because this is a constant, this will go to 0. Then I differentiate this, plus the derivative of the function. Okay, so this. Okay, then the next thing is I compare. So let's compare. So you differentiate and compare with n. So you compare with the function n of what? X what? Y. If it was the other way round, if I did the integration with respect to the n, x, y, then after differentiating, I'll compare with what? M. So what is n? N is what? 2xy. Don't forget our n is what? So let's say n of x, y. We know it's equal to what? 2 what? X what? Y. So we are comparing this. So you compare this u with that. So if you compare, what do you realize? You realize that you have I have this. So this is what I have. I have partial derivative of u with respect to y is going to be what? Equal to 2xy plus the derivative here of the function what? Y. Okay, so if you compare, we have this, we have what? That. So how about that part? So you realize that. So therefore, from here, you realize if we compare this and that, I have 2xy, 2xy. So this derivative, you realize is going to be what? Plus what? 0. So let's say this is equal to plus 0. So then my derivative here of y, which is the derivative dphi dy, it's equal to what? 0. And if I want to find what y is, so let's say we want to find the constant function phi of y, what do? If it's a derivative, then you what? You integrate. So that if I integrate, what do I get? Or the question you ask yourself is, what function will you differentiate to get what? 0. So it is always a constant what? Function. So you always differentiate what? A constant function to get what? 0. So that if differentiate a constant to get 0, it implies that what? This function is actually what? C. It's actually what? C. Because it's only a constant that you differentiate to what? Get 0. So then this implies that, or therefore this implies that our function or our solution of f of fxy is going to be what? If you take the integral here, so let's check. We had u, which is u is going to be u, which is the solution, is going to be what? X squared y minus what? X squared plus our constant function, and this time our constant function is what? C. So this is what? The solution to with the differential equation, or you can equally write it as C to be equal to your x squared y minus what? X squared, because that is what we have here. And this is the solution we are looking at. So go write it in this form, or you have that. So this is our solution to the differential equation we had from what? Onset. So that is another way to look at what? An exact differential what? Equation. Till our next lesson, kindly stay safe. Bye.